Hi everyone, my name is Jen Monshine. and I'm the Director of Sales for KiiNjA Corporation. KiiNjA Corporation is an OEM manufacturer located in Fort Collins, Colorado. We manufacture supercritical CO2 machines. We have had the pleasure to spend the week here with Dr. John MacKay. And John MacKay has quite an extensive history of working with CO2 and other types of extraction. So I'm going to let John speak for a little bit about himself and who he is. And
thanks for the introduction. I've spent a lot of time here in Fort Collins. I lived here from 90 to 94. I think the city's expanded, but so has the opportunity for a lot of industrial things that have happened in the cannabis world, and now even more with the hemp. So as far as my work within this part of the application world with extraction and using cannabis and using hemp, all those things come from two things. One is my fascination with the fact of having equipment that's been used since the 1940s being repurposed for this process, and having that revitalization of extraction, revitalization of concentration, the revitalization of the agricultural for having a plant that allows the farmers to make more money. But I came through this process with a PhD in synthetic chemistry, and back in I made my first injection for chromatography back in early 1972. So that's been more than 3 years. I think even simple math brings me there. And so when I go back through, it wasn't in 2012 that I became even knowledgeable about the extraction with cannabis. And about that time is when there was a lot of things that happened, especially for Colorado, with the upcoming election and all the things that came to purpose. And suddenly people were reinventing extraction. So during that time, I looked at the entire process and thought, from the time that the plant comes in until the time that you have an oil that you're making into another product, I thought that was the fascination part. And there were very few papers at the time. There were a few patents, so I would read those. But it was, I would say, in this industry, what I did is in probably November of 2014, I'd heard a talk. 2013, I heard a talk, and it was during that time they said, if you study an hour a day, you'll be the best lawyer in 3 months. And I thought, well, I don't know anything about law, and being in the illegal industry, probably that was a good thing. So if I move forward, I decided to start reading the academic papers, and I still do it today. So I'll still get up and I'll read for an hour and a half on the most recent literature on what's happening on extraction, or what's happening in the cannabis industry, or what's happening in the legality side. Right. And so it's that accumulated time of 1 hour since 2013. It's almost November again, so quick math brings me to 20 minus 13 brings me to 7. And so you take 7 times 360. I'd probably have to round up. 7 times 307. Is that 21,000? It's a long time.
Something like that.
So when you're looking at that process, that's the accumulated amount of knowledge that I have in this industry.
Right.
That's how I got here.
Fascinating. So you've been with us here for a week up in Fort Collins, working on our Kinetic, playing with it a little bit this week. I know you've worked on probably almost every CO2 machine in the market today. I'm wondering what your thoughts are on the Kinetic.
So on the Kinetic. So there's a lot of key parts of an extractor. So this actually will come around to something that makes sense. And that is, you have an extraction vessel, you have a collection vessel, and in between you have ways of keeping the CO2 inside the steel tube in a certain temperature and pressure. That's fairly simple to do. All you really need is a CO2 canister. You need to have some sort of heat exchanger to make it cold enough. Then you bring it through a pump. It goes through that pump, and then you come out the backside. So I would say that on that side, the Kinetic, it matches everything. Then I start to bring myself to analogies, because I love analogies. And so if you have a go-kart will bring you to the store. Not during a snowstorm, but it will bring you to the store. A bicycle will bring you to the store. Actually, a cart you can just a wagon with someone pulling the wagon will bring you to the store. And so those are the key parts that you have. Now, if you move towards that and you live in Colorado, for example, and you need something to bring you up and down mountains, that's typically four-wheel drive. It typically is cold on those mountains that it has the snow, so you want that heated steering wheel, and you want the heated seat. So you take care of your hands and you take care of the rest of your body because you have the warmth there. And you want to have something that allows you to have enough power to go up the mountains. There's nothing like a good go-kart going ding, 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 ding. You really want to have the ability of moving up because when you climb up these mountains, you want to have the ability of going by the person that has the go-kart or doesn't have the chains and is spinning in front of you. And I would say that that's what the Kinetic does is it's future-proofed itself so it's enabled for where the market is going to end up in the next 2 years. And I would say that that's the part that I probably have enjoyed the experience the most of, is as I journey around behind it and peek at all the tubing and trace where all the different components are going. It really is a single setup that's enabled for where the future is going. And so I think that there's a lot of features that are in there that other companies don't have, and they're going to have to be compliant for a food grade world where people want to say, oh, I want it to be federally legal. Well, when it's federally legal, then they're going to have equipment that provides them that solution that is OSHA, that is compliant with good safety standards.
Right. So that leads into a good question. Where do you see the future of the market going?
So the future of the market. So I would say that when it becomes legal, then the FDA is going to have site people that go to visit a site like you do in the food industry. For example, you typically have a Q-tip. It's not called a Q-tip when you actually use it for cleaning validation, but when you take that, you're going to want to take that Q-tip and wipe every surface in between days or in between analyses. And if that Q-tip is then shoved into an analyzer and seen that it has other material in there, the cannabinoids from a last run or trace amounts, then you can't run yet. And so how are you going to clean that entire process off? So I think having the automatic cleaning validation, being able to do the cotton swab and show that you're not getting something out of each one of the inside of the vessels, inside the tubing, is going to be critical. I think the other one too is that if you look at the dietary nutritional supplements, when you look at that, it says that you have to have the same product being made. So that's accuracy and precision. So when you ask it to do a certain flow rate to be able to provide you a product at a certain pressure and temperature, then you're going to want to have that come out. You're going to want to have those same conditions. If I'm making caramels, I'm going to want to make sure that I'm not heating it past the burn point.
Right.
I'm going to want to make sure that my stove is going to give me a correct temperature. If I'm making cookies for Thanksgiving, I'm probably not making cookies for Thanksgiving, but if I was making cookies for Thanksgiving, then I would want to make sure that my oven had consistent heating.
Correct. Yeah.
There's a difference between what you're going to make for cookies and I'm going to make for cookies. I don't know that
Are you
works.
sure?
No, I don't know if that works, but we'll
go with that. We'll go with that.
So really, if you take a cookie pan and you take your stove and you put in those cookies that all look like little reindeers, okay, they don't have to be little reindeers. That's wrong. If you have stars or clovers, you need a shape. I'll come up with a shape. So when you have a shape of a cookie and you put it in there, and then you have other shapes that are bigger than that. So now you have a big heart, and you have a little heart. And so you take those two things, you want to make sure that those two are going to cook at the same time. There's not a chance that they're going to cook at the same time because you have a big cookie and a little cookie. Right. So number one, you want to have the same, I'm making this up. So number one, you want to be able to have the same size cookies because you want to have uniformity. And then the second thing is if you do have those cookies and you see that the ones around the outside of the cookie are a little bit brown and the ones on the inside aren't, so now you have disparate heat on your oven. That doesn't really matter because nobody cares at what you're making for a cookie. They don't care.
They don't care.
They don't
No.
care. They're going to eat your cookies because they're sweet.
They're going to eat them anyway.
They're going to eat them anyway. But if you're a manufacturer of a big manufacturer, you're going to want to have content uniformity. And the way you get content uniformity is having uniform conditions, precision, accuracy. You know what your flow rate is. You know what your column volumes are. That's how you know how much CO2 has been used. Each one of those parameters is going to be important. You're going to want to have the same CO2. You're going to want to make sure your CO2 doesn't have water the next time around. You're going to want to make sure your CO2 is as pure as it was the first time. You're going to want to make sure that when you're going into the vessel, it's actually spraying across so you're not having channeling. You're going to have all those little features that I've witnessed this week, and being able to have those in place. Does it matter? No, it doesn't. It doesn't. It doesn't matter when you're just making cookies at home. It matters when you're doing content uniformity, and that's what OSHA's going to want to make sure that it's safe. They're going to want to make sure there's multiple ways of seeing the pressure and temperature. They're not going to want to remain on digital. They're going to want to have feedback. They want to know what you put in for conditions and what it actually ran on that batch. Everything that comes through that process.
Wow.
That was a little longer than probably you wanted.
I thought that was fantastic.
Well, you're low threshold.
Well, potentially. I thought it was fantastic. So what do you see as some common challenges in the extraction world?
So the number one common thing is that people came out of a cottage industry and from there used their knowledge of changing one thing at a time and coming out with a process. And at the time, there wasn't that much being done. I mean, 5 liter vessel, 3 pounds, using a KiiNjA blender, and then putting it in. And then you had multiple KiiNjA blenders because the propeller would get hot, so you had another, you put that over on the side and use it. And so what happens is you didn't really have product uniformity, and you also probably weren't wearing masks, and you probably weren't doing it in an industrial setting right next to the sheriff's office. And so when you do that process, now what you have is you have process control. You have grinders that bring it to a certain millimeter size. I like to use between 4 and 5 for CO2. I like to use a little bigger for ethanol, use a little bit different for propane, and then you have those processes. And then you have a pre-process of how are you loading it, and how are you, reducing the dust from that? How are you making sure that people are safe during that process? And then you move towards the extraction. And in the early days, it really was just a vessel and a great big pump going and just putting CO2 through something, and then having one collector. And then there was the next regulation that said closed loop, and everyone went, "Oh, closed loop, okay. What's a closed loop?" Well, that's where it doesn't go round and round. I mean, it doesn't go out to the atmosphere; it goes round and round. And so then you had that part. And so I think that when you take all those challenges, the challenges is how do you now merge the chemical engineers, not that there's anything wrong with them, but a chemical engineer, bringing them through the process, the chemist with the professional degrees behind him, along joining with the cottage industry of all the things they knew. And so merging those all together, but also being able to have something that's, number one, as I have always said, it's got to be safe. It doesn't matter what happens, it has to be safe. Safe. Efficacy. And then from there, you're wanting to see, does it actually do something? Whatever that product is, so you're not adding things into it. And then the third one is economics and efficiency, because once you have the economics and efficiency, now you're looking at, all right, I need to stay in business to provide products that are appropriate for the customers that are going to buy them, and to stay in business. And so, when you have a capital investment, you're going to want to make sure that you have that time. As I look at where the industry came, it came from not having a fast a process, and so it would take 18 hours to do 5 pounds.
Right.
And now, even looking at the small amount of work that we've done, with 10 pounds, and you take 10, so you're doing 5 to 6 pounds every, 20 to 30 minutes. And it's a matter of how fast can you reload, how fast do you reload, how fast you reload. So now you have all those things in place.
Right.
So that's part of it. And then the other one is the amount of other materials. I think people are starting to understand concentration. So if you have something at 0.3 of THCA in your plant, and you have something at 7% of CBDA, and then you're all excited because you've concentrated your CBDA to 4x, we'll say 4x or 5x,
sure.
And now you're up to 35%. That's very exciting.
Right.
And for some reason, they don't believe that all the other components are also concentrating. They're all concentrating. So now you've gone from 0.3 times, let's say 7, so now you're up to 2.1, which is federally illegal.
Correct.
Nothing good is coming next.
Right.
Now you have to get rid of it. Well, if you have the opportunity to use a sophisticated instrument to reduce that amount in the beginning, now you can take advantage of solubility. You can take advantage of all the different things that a high performance instrument can do. And that's the difference. So now you have yourself a car with not only heated seats, but one that move back. You can move forward. You can move. This was forward. Backwards. You can go up and down, rather than underneath, or ones that didn't move.
Right.
So those are the things that you have. I'm not sure if that answered the question, but it was a lot of.
I think it answered a good majority of the
I wasn't
question.
sure if I'd just done presidential debate rerun.
No.
No. You have other questions?
No.
You should.
I do have other questions. I just
Okay.
didn't write them down.
So when you're looking at a number of different things you have, and that is, who cares about the fact that you have something that allows you to come up from the bottom of your extractor and spray across the material in a uniform manner? And when you look at internally what happens with an extractor, the early extractors all had a nozzle, and they all moved up. Some had a nozzle and then a 5 micron fritz, so you'd spray up through that, and you'd also have a plume of different things. There's a lot of different ways to do it, but I think each one has to be able to look at that process. And so now you have something that you say, well, it's just another module. When you look at the Kinetic, it also has the check valve, so it means that you actually could take that same vessel and not only add biomass to it. I mean, it's pretty simple. You add biomass to it, and then you're able to do an extraction. But what if you were able to just, you can do the experiment, but you can just take a gallon of water and pour a gallon of water in your extractor.
Right. And
then when you go back through and you say, well, first of all, why would I do that? Well, same reason that you throw, dirt on the rug when you're a vacuum sales guy. It's pretty much the same thing. Oh my gosh, you've got dirt on the rug. Looks like we can take care of that. And that's why I would choose to have something like that. So now you throw water in, and if you can show on the backside that your CO2 that's being used on the next batch comes up is dry, and it's as dry as opening up a brand new tank of CO2, then you've accomplished the fact of saying, it's not that no one else can do that, but it'd be interesting to see if other people could do that. And those are some of the parts of looking towards the future. Not saying, okay, what is everyone else making? I'll make something that's adequate. There's a lot of things that are adequate out there. Not that adequate isn't bad, so I should say adequate. So now you have things that are adequate. And now you have to, if you raise the bar, now you've raised the bar to say, what else can be done? And so you can think of some of the other things that we can talk about in another podcast, and that is podcasts or whatever I am doing. Ubecast. So if I'm doing those things, I can go back through and show other parts that are possible. The other one that you have is small things like being able to make sure that when you adjust something, that it's a click and it locks. It's
right.
not. It's going to lock in place. It will not allow you to turn it on.
Right.
I don't know of any other systems that allow that amount of segregation, that you have to be able to make sure it's a click. It rotates in. You're not having to, I have not yet this week taken out my 9/16 wrench, and I have some of my favorites.
That's good to know.
And I have not used one.
Good to know you've
My
not had to
3/8,
use
my
one.
1/2 inch, my 7/8, 7/16. I haven't used any of them. I have not taken out a wrench. I have taken out a pencil twice, but I've not taken out a wrench.
Good to know. Good to know. So you're going to be here with us for some time here in the next few days to few weeks, and
sorry.
No, we're I'm sorry you're sorry, but we're not sorry. We're very excited that you're here. So do you have some ideas or things that you're excited to start experimenting with on this particular instrument?
No.
Why not?
No. So I think one of the things to prove to myself, and that is that when I take the same biomass and I take the same column volumes, that when I put my collection vessel under there, that I'm going to gain at 15 column volumes, I'm going to have the same, nearly the same. What amount of accuracy am I going to have? The same amount of material is going to come out after those 15 column volumes. You're assuming, number one, that you've got the material up front is statistically valid, and so you have that. And then you move towards that process, and you say at 15 column volumes, I'm going to get. This is a bad example, but I'm going to get this much oil, and this much oil out of that separator is going to be plus or minus 1% of what I got last time of CBC and CBD or CBDA, and I'm going to get that time and time again, where I don't have to think about, I wonder what it is this time.
Right.
I can't wait. I'm so excited. I can hardly wait to open up the valve. And so now you have the capability of having anyone run the system and knowing that you're going to get I'm going to make up a number. I'm going to say 25 to 26% CBDA. I'm going to get, less than 0.3% THCA based on my conditions. And I'm going to have things like this one, where this looks the same as this, but they are vastly different. These are two samples that are taken from two different separators. And though they look identical, this one kind of moves a little bit, flows a little bit easier.
Yes, it does.
The content of these two oils is significantly different.
Mm-hmm.
And we put in place criteria that allowed us to know that we were doing something different, but we have to go back through and then know that it's always going to be the same.
Right.
This one here, these two little samples, this one is our starting material from not starting material. This is material that we'd gotten from a separation, and this has about, as I remember, probably 5 to 7% still of nonpolar lipids and carbon chain hydrocarbons, and this one is almost none. So this is already sitting well over 70%, nearly 80% if I remember. And with that, you've now eliminated much of your degumming steps. You still might have to do some degumming for the lower lower chain carbons, the carbon 18s and stuff, but that allows you to do that with the same instrument. So when I'm driving a car in Colorado, I can actually go to Breckenridge or I can go to Vail, and I can use the same car. It's unbelievable. And I could go to Safeway or I could go down to Denver. I can use the same car. But I programmed it to go to a different place. And that's the power of what this does. When you take a train isn't going to Breckenridge or Vail, and it's not going to stop off for you because you're hungry and you want to go to McDonald's again. And so when you do that process, a lot of times you have things that are trains, and this is a high-performance automobile that I can make unique products, whether it's lavender or whether it's cannabis or whether it's hemp or whether it's a CBG. Each one of those is a very different compound, but you can make it over and over and over again. I can use an oven to make chocolate chip cookies, Valentine's Day cookies, bread. I can warm my French toast, pizza.
Yes, indeed. I get that point. Well, it sounds like you have some exciting things to do going forward in a machine that you'll, I'm sure, no doubt, have some fun toying with.
Yes.
For lack of better words.
Do you want to do this again?
Sure.
I mean, really again, right now?
Sure.
Yeah, okay. I feel warmed up.